All right, this is the completion of the problems that we were looking at from section 6.2. We did not get through all of those today. So we left off at this problem right here. Find the value of all 6 trig functions given the following triangle. Again, we are missing one of the legs of this triangle. So we would have to plug into our a squared plus b squared equals c squared, where the hypotenuse in this one is going to be across from the right angle. It's going to be 100. So this is going to be 6 squared plus b squared equals 100 squared. So that would be 36 plus b squared, and then 100 squared is 10,000. Actually, I think this is a typo. I think I accidentally typed in another 0 here. I think I wanted this to be 10. Yeah. Looking at my original printout. So I think when I was editing that, I accidentally hit a 10, another 0. This is supposed to be 10. Because otherwise that was going to be really big, large numbers. So this is 100 because I wanted this one to work out to a perfect square. So this is going to be 64. So square root of that is 8. And this is one of those special triangles that they all have these nice ratios where all the sides, none of them have square roots attached to them. So we're looking at, they're called Pythagorean triples is what they are. So we're looking at making the sine. So we have to look at a reference to our angle. This would be opposite. This would be the adjacent. And of course, the largest side is the hypotenuse. So then for sine, we do opposite over hypotenuse, which is 8 over 10, which reduces down to 4 over 5. Cosine is adjacent over hypotenuse, which is 6 over 10, which reduces down to 3 over 5. Tangent is opposite over adjacent. That would be 8 over 6, which reduces down to 4 over 3. And then remember, cosecant is the reciprocal of sine, or the inverse of that. Secant is the inverse of cosine, and tangent and cotangent are inverses of each other. So reciprocal for the ratio. Okay, let's look at this next one. It says if cosecant of theta is 3 over 2, find the other 5 trig functions for this acute triangle. And that should say acute right triangle. Remember, all of these have to be right triangles for us to do this. So let's draw our picture and remind ourselves that if we know cosecant, we also know sine would be 2 over 3. So if this is my angle theta, that means opposite is 2, hypotenuse is 3, and I can use Pythagorean theorem to find the missing side using the hypotenuse as c, so 3. So this would be 4 plus x squared equals 9. Subtract over the 4 and get 5. So this is the square root of 5 if we solve that for x. Okay. And then to make our other ratios, so we already know sine and cosecant. Those are there. So we need cosine, secant. It's a little too close. And tangent and cotangent. Cosine would be adjacent, which is square root of 5 over the hypotenuse, which is 3. We need tangent to be opposite over adjacent. So that's 2 over the square root of 5. We'll need to rationalize that. So that's going to be 2 on the square root of 5 over 5. Secant is going to be the reciprocal of this one. So that's 3 over square root of 5, or rationalized, it's 3 square root of 5 over 5. And cotangent, you want to, instead of flipping it here where the radical is going to end up in the bottom again, you want to use the 2 over square root of 5 before we rationalized it. So that's going to be square root of 5 over 2. So there are the other 4 plus the one we got from this being inverses. So that's 5 trig functions we were looking for. All right, let's talk about this next one. This one had a typo. It was supposed to be, it auto-corrected. It was supposed to be cotangent. If this one was a cosine, it would not make sense because we would end up getting a hypotenuse that is smaller than our other sides, which does not make sense. So notice this one is going to be, if cotangent is -3/2, that means that tangent is going to be -2/3. So we have those. And we have, we don't know, we know this is opposite. So let's call this our angle right here. For our sketch, we know that this is 2 and this is 3. We don't necessarily know which one is negative, so you can just put it on one of them. And then we have to find our hypotenuse. So this is, we know both of the legs, and we're looking for the height. So that's 4 + 9 = c squared. That's 13 = c squared. So square root of 13. So we need sine and cosecant. And we also need cosine. Oops, I'm drawing theta and it's supposed to be phi. And secant. So sine would be opposite over hypotenuse. So 2 over the square root of 13, which is going to be 2 square root of 13 over 13. And then we also would need to do the reciprocal of that. So that's going to be square root of 13 over 2. And then we have cosine, which is adjacent over height. So that would be -3 over the square root of 13, which is -3 square root of 13 over 13 when we rationalize. And this would be negative square root of 13 over 3. So yeah, and I chose to keep the negative on the 3 because that's how this is written in this ratio. It was technically written with the top number, because if it was written with the bottom number, that would still be a negative fraction overall, but it would change these ratios where we would have had, we had cosine and secant were negative. We would have had sine and cosecant would have been negative. So the negative does matter, but I just went with the, and I need to make that clearer with what I wrote here. I went with the original, that this has just been brought up to the front. I went with the original, which was saying -3 divided by 2. All right, so let's look at, these are special angles again. So notice that if you have 0 degrees, 0 radians, this is going to be, problems that we're going to look at. The hypotenuse is exactly 1 in length. So let me actually share. This is one of those I wanted to share the PowerPoint because the graphic was really good of how they come up with this. So let me just make sure I'm sharing that correctly. Yes. This is kind of a proof to prove those different ratios essentially that you get for all of those. So if you look right here, if you take a equilateral triangle, which means all angles are 60 degrees, if you cut that in half, that makes this a 30-degree angle, and this is now a right angle because it's dropped perpendicular down. So if you had, let's say, all the sides of that triangle had been a 2, so all 3 sides are 2, and the reason we make it that way is because when we do this split down here at the bottom, we can see, let me see if I can draw on this. We can see that that actually splits this in half. So if we made this a 1 on each of these, like say all 3 of our sides had been 1 originally, these would have ended up being 1/2. And so just to make it a little nicer, if we start with all 3 sides being 2, cutting it in half makes each of them a 1. And then you use the Pythagorean theorem to figure out that, okay, if this is 2 and this is 1, 4 minus 1 is 3, and then we take the square root to get this side. So that's why in a triangle that is a 30, 60, 90, a special name for it, you're going to notice that the ratios we get are very specific. If we reference the sine of 30 degrees, notice that we're going to get opposite over height. So sine of 30 is a 1/2. Whereas if we did cosine of 30 degrees, we're going to get adjacent over hypotenuse. So square root of 3 over 2. If we do tangent of 30 degrees, we're going to get opposite, which is 1, over adjacent, which is square root of 3 That's where the square root of 3 over 3 comes from. It's that rationalizing step. And if you do sine of the 60 degrees, notice that you're going to get opposite over hypotenuse, so square root of 3 over 2. You're going to get cosine of 30 degrees or 60 degrees, not 30, is the 1/2 again. And tangent of 60 degrees is square root of 3 opposite over 1. So if we go back and look at that table, you can kind of see some of those pieces there. So see, look, the 30 degrees, these are the radians for that, but these are the actual ratios. And then, of course, cosecant, secant, and cotangent are found by, remember, reciprocals of these. The 60 square root of 3 over 2 for sine, 1/2 for cosine, square root of 3 for tangent, and then the reciprocals. We're going to talk more about the actual one, the 0 and the 90 when we do the unit circle. Those are special cases because when you're at those, you're at a quadrant essentially. So you're really just dealing with the ordered pair 0, 1. And we'll talk about like that. I said more on the day that we do unit circle, which is Tuesday. But let's talk about the 45, 45, 90. So let me go back and see if that was in the PowerPoint as well. I believe it was. Yes. So if you have a 45, 45, 90, the two sides that make up the legs have to be equal because they are across from these equal angles. So that makes that 1 and 1. Just to make it simple, because you can make it 4 and 4 if you want, but essentially the ratios are going to produce down to what we get. So if we add those two together and we'll square them and add them, so that'd be 1 squared plus 1 squared is 2. Take the square root, we get the square root of 2. So notice there's only really one interesting angle since they're both the same. Sine of 45 degrees, if we look at this one, it's going to be the same if we look at this one though. It's going to be 1 over the square root of 2, which is square root of 2 over 2. And let me make sure I'm actually sharing, yes, my PowerPoint. And then we look at cosine of 45 degrees. That's also adjacent over hype is also 1 over the square root of 2. And then if we look at the last part, which is tangent, that is opposite over adjacent, which is 1. So that helps you see kind of, they didn't just make this table up. It actually comes from looking at specific special triangles. And then when we do unit circle, you'll understand the 0 and 90 degrees more. So where is that useful? Well, we can use it in solving some application problems. So if you look at this, it says if a tree stands 22 meters tall, how far are you from the tree if your angle of view is 30 degrees to the top? So that's a special angle that we just learned about. So to solve this, we draw a picture as shown on the left. The tree is on the opposite side, so that's its height. And the angle is 22. Yeah, and the height is 22. Sorry, I was reading backwards. Our goal is to find that adjacent side because they said, how far are we from the tree? So that means we're solving for this, okay? So if we think about it, and this is just the general setup, tangent of 30 degrees would be opposite over adjacent. Or if you wanted to look at it a different way, you could cross multiply and think about that and say adjacent equals 22 over tangent of 30. Which we know tangent of 30 from our table up here is square root of 3 over 3. And then we could simplify that. I like to do it a little differently than some of the directions here. The way that I like to set it up, and I essentially just write the following. I still write tangent of 30 degrees is 22 over my x. And then I replace tangent of 30. Since I actually know that's square root of 3 over 3, then I'm not really trying to do it with words. I've already made the substitution. And I just have to cross multiply. So that would be square root of 3x equals 66. Divide by the square root of 3. And depending on if they wanted that rounded or not, you know, or if this was just give us an exact answer, I would still maybe rationalize that. And multiply top and bottom by square root of 3 over 3. Square root of 3 over square root of 3 gives me this, and that would be 22 on the square root of 3. That looks a little bit nicer to me.